In this video, we're going to have a look at trig ratio applications involving 3D situations. Our first example is to consider the rectangular prism shown. So we've got a base of 20 centimeters by 5 centimeters with a height of the shape at 3 centimeters. What you can see is a dark pipe that has been laid into the rectangular box. And that's the longest length of pipe that we can fit into this box. So we want to find this length of pipe to the nearest, or as an exact value. So first of all, we need to use our trig ratios, which means right angled triangles, to form that length. So in a 3D situation, we're going to create a triangle with that vertical outer length. I'm going to call that from point A to point B, and from B along the base of that rectangular prism to our point C. This, in fact, is a right angled triangle because we're using the base of the prism and the vertical height of the prism and just creating that hypotenuse, that longest side. So what we now have is from point A to point B, that's 3 centimeters. From point B to point C, we have no idea what that length is, and we want to find this length AC. That's what we want to find. So what we actually need to do first is, how do we find the length BC? Well, the length BC is actually the hypotenuse to another right triangle we can create on the very bottom of our rectangular prism. It's a bit hard to imagine that this would be a right triangle, but if you grabbed a rectangular prism around your house or in the classroom like a tissue box and actually looked at the rectangle on the base of that tissue box, we're calling these points B and C. We want to find that length BC that runs diagonally, so that would therefore mean that we're using those edges of that tissue box base, which means the base of this is a length of 5 and a length of 20. So in fact, we can find this length BC. So let's do that first. So BC is obviously going to be found using Pythagoras. It's the hypotenuse of that triangle, so 20 squared plus 5 squared. So this is going to give us the square root of 425. So we can either grab our class pad and type that in to main in standard mode, and that will tell us how to simplify, or we can see that's just 25 in there times by a certain amount, lots of 25 that you're going to find in 425. So if you want to pause the video at this point and actually type that into your calculator to see what that comes out as, we're going to end up with 5 root 17. Okay, and that's in centimeters. So now that we know that this is 5 root 17, we can work out AC, the length of the longest pipe. So again, we're going to use Pythagoras because that's going to be the hypotenuse of that first triangle. So that's going to be 5 root 17 squared. Well, we know that's 425 plus 3 squared. So we've got the square root of 434. So again, we can grab our class pads and keep it in standard mode to work out, is there a way of simplifying the square root of 434, and we find there isn't. So it's the square root of 434 centimeters. Okay, therefore, so the longest pipe as an exact value is the square root of 434 centimeters. The angle that this pipe makes with the ground, well, that means the ground obviously means the base of, for example, a tissue box. So when we go back and have a look at our first triangle that we've drawn of our ABC triangle, we now know this is 5 root 17 and 3 and root 434. We want to know this angle theta here, and that's the angle on our actual 3D shape that we're making with the ground, that length BC. So that's nice and easy. I'm going to use these easier values. So I'm going to use the tan ratios. The tan of theta is 3 opposite over 5 root 17. And we can find that as a decimal, it'll be much easier, as 8.28 degrees to 2 decimal places. You can check that on your class pad. So let's consider our second example, which is a square-based pyramid. We all know pyramids have a certain size base and a certain shape, but all the sides that create the 3D part, the pyramid part going to the top at an apex, are all triangles, except obviously for a cone. So it's telling us that we've got a vertical height from the base to the apex of 15. So I'm going to draw that into my diagram here. That vertical length is 15 centimeters. The base is an 8 centimeter square, so we can place that information on our diagram. We want to find the angle each triangular face makes with the base. So here we've got a triangular face. I'm going to highlight in yellow. And we want to know what is the angle that makes with the base. So we need to create a right angle triangle here. So we've got the 15 centimeter vertical height. We can bring out a length straight from across the base on our square, and then use a slant height, which is the height of that slanted triangle face. And we've created a right triangle. So removing that information from the picture, we've got a 15 centimeter vertical height. We've drawn a baseline halfway across our square base, so that will be 4 centimeters, and that creates a right triangle. And I want to find the angle that face makes, and the face is represented by what I'm highlighting in yellow, by that line. And so we want to find that angle theta. So again, I'm using the tan ratio, the opposite over the adjacent, so 15 over 4, and the angle will be 75.07 degrees. So because that that square base prism is quite tall at 15 centimeters compared to a base, the angle will be quite steep, but obviously less than 90 degrees. So in our final example, we've got a little bit of a context here of looking at a hill ABCD. So we can see this hill ABCD rises at an angle of 15 degrees to the horizontal. So there's our angle of 15 degrees. So our horizontal is represented by that line DE. So we're going to call that our horizontal. Okay. So if the hill is 100 meters high, which we've got noted on our diagram, how long is road DA? The line of the steepest slope of the hill. So we can clearly see we can identify a right angle triangle just on the right edge of our diagram from A to D and out to E. Length AE is 100 meters, and we have an angle of increase or incline of this hill of 15 degrees. So because we've got an angle, we can look from this angle and we can find that length DA. And I'm going to just label that DA, that length. So looking at this, we can say, I know the opposite side and I want to find the hypotenuse. So I'm going to use the sine ratio. So the sine of 15 degrees is the opposite side over side DA. So I'm going to multiply and divide. So 100 divided by sine of 15 degrees. That DA is a length of 386.37 meters. So it'd be great to pause the video and just confirm that you're happy with that calculation. So in part B, a man travels up road DA in a northerly direction. So he is traveling up DA. So DA is traveling north. So that's really important to note. How far has he traveled horizontally? So if he travels all the way up from D to A, what is his horizontal distance? The horizontal distance would therefore be represented by DE. So we've got all the information we need to find DE from our previous question. So using that triangle, that right angle triangle we've created, we can find DE, and we can do this by either using again a trig ratio, or we could find it using Pythagoras because we actually know DA, the hypotenuse, and a shorter side. So if we're using Pythagoras, DE would be the square root of dA squared. Take 100 squared and we could work that out. Otherwise, looking from the angle of 15, we can say the opposite and the adjacent side. So we could do the tan of 15 is 100 over dE, and we're going to find that dE is 373.21 meters, which is our horizontal movement. So now I'd like you to pause the video and have a go at part C. A track CA is 700 meters long. Find the angle theta of the track, this track to the horizontal. So let's have a look back at our diagram. Let's highlight CA in green. We've got a horizontal and it makes an angle of theta, which is highlighted in our diagram. So what I'd like you to do is work out what that angle is with that horizontal. And the horizontal means the base of our hill, represented by CE. Pause the video and come back and check your solution. Okay, so just drawing a right angled triangle to represent our situation. We've got CA, which is 700 meters long, and CE, which is the base of the hill. We know AE is 100 meters. We want to find angle theta, the angle that track CA makes with the horizontal. So looking from point C, from the angle, we've got the opposite and hypotenuse. So we're going to use the sine ratio, but this time we want to find the angle. So we're going to inverse sine 100 over 700, and our theta value is 8.21. So therefore we can say that track CA is 8.21 degrees to the horizontal, represented by CE.